Even walked into a massive skyscraper and just looked up and thought, what is actually holding all of this up? It's not just the walls you see. Kind of like our bodies, every building has this invisible skeleton, a hidden framework that gives it all its strength. And today we are going to pull back the curtain and show you exactly what it is. Okay, so let's just ask the big question right out of the gate. What keeps a building from, falling down? How does it deal with its own incredible weight? Never mind a crazy gust of wind. Believe me, the answer is a whole lot more complex than just the walls and windows you can see. Well, the short answer is its structure. You can think of it as the building's skeleton and muscles all rolled into one. It's meant job to handle every single force, or what engineers call loads, that's thrown at it. And to really get how it all works, we are going to follow one of those laws on the little journey. Alright, so to make this super clear, let's follow the journey of a single load. Just imagine, say, the weight of your desk, your chair, and you sitting on the 10th floor. We are going to chase the path that weight takes from right where you're sitting all the way down until it's safely transferred into the earth. So, this downward trip has four main characters, four key players that handle these vertical loads. And where does it all start? It starts on the very surface you're standing on, the floor, or as engineers call it, the slab, right? So the slab is ground zero. It's that big flat horizontal surface that makes up the floor, and it's the first thing to feel the weight of everything. People, furniture, all of it. It takes that initial hit, but where does that weight go from there? Okay, so from that white flat slab, the load gets passed off to the beams. Think of beams as the horizontal supports. You often see them in ceilings or sometimes they are hidden. They're like a network of bridges, collecting all that weight from the slab and funneling it sideways to getting ready for the next step. And this is where things get interesting. The beams funnel all that spread out to specific points. And those points are columns. You know, those thin vertical pillars you see in places like a parking garage or a big open lobby. Yep, those are columns. And their job is to act like express elevators for the load, taking all that L concentrated weight and shooting it straight down floor after floor. And here we are, the final destination. After that, right down at the columns, all that weight, the entire collected load of the building hits the foundation. And the foundation had one critical job. Take that massive focused force and spread it out, kind of like snowshoes on snow, transferring it safely into the crowd. And just like that, the vertical journey is over. Okay, so we've got gravity handled. But guess what? That's only half the story. Buildings have to fight forces that push them to from the side too. We're talking wind, earthquakes, and that is a whole different ballgame for the structure. So let's break this down. Everything we've talked about so far. So uh, those are vertical loads, gravity pulling stuff down, simple enough. But lateral roads, they push things sideways. I mean, just imagine the incredible force of a hurricane level wind pushing on the side of skyscraper or the ground literally shaking beneath it during an earthquake. So how do you fight that? Well, buildings need a fifth absolutely crucial component, a lateral force resistance system. This is the building's core strength. Literally, it's what allows it to brace itself to keep from swaying like a tree in a storm or, the worst case scenario, collapsing under all that sideways pressure. And there are a few different ways engineers pull it off. Sometimes they use these super strong solid walls called shear walls, which basically acts like a building's spine. Other times you might see those steel beams in the big X shape. Those are called braced frames, and they make the structure incredibly rigid. And the third way is to make the joints where beams and columns meet so incredibly strong and stiff that they just can't bend. That's called a moment frame. Okay, so we've got the system that handles gravity and the system that handles sideways forces. Now, let's talk about the last few pieces of the puzzle that tie this whole thing together and turn it into one complete working structure. Let's clear something up about words because this is a big misconception. Not every wall is holding the building up. Some are. We are calling those load-bearing walls, and they are doing a heavy lifting just like a column. But a lot of the walls you see, they are not load-bearing. Their only job is to create rooms, keep you warm, and provide fire safety. There dividers not part of the core skeleton. And that brings us to the final two pieces of our puzzle. First, you've got the roof structure, pretty self-explanatory. It keeps the weather out, but then you have what I think is the unsung hero of the whole operation, the connections. We are talking about thousands and thousands of bolts, welds, and joints had hold a very single piece together. I mean, without them, you don't have a system. You just have a big pile of steel and concrete. So you add all that up and there you go. Eight. Those are The eight core components that make up the invisible skeleton inside pretty much every building you're that ever walked into. But here's the absolute key thing to remember. It isn't just a list of eight separate parts. They're not just stacked up like building blocks. No, it's one single integrated system. The slab relies on the beam relies on the column, and that lateral system is there protecting all of them. Every piece has a job, and it can only do that job because all the other pieces are doing theirs. It all works together, so I want you to try something. The next time you walk into any buildings, uh, an office, a library, your own house, just stop for a second. See if you can spot the columns. Try to imagine the beams hidden up in the ceiling and the foundation buried deep beneath your feet. Because now that you know about this invisible skeleton, I bet you never look at the building the same way.